In this video, let us solve problems based on tangents to a circle. Now, we've got a problem here which reads like this. In the figure given here, if AB equals AC, prove that BE equals EC. So, a pretty straightforward problem. So, let's see how do we go about solving this problem. So now, before we start off this problem, we need to remember, all the properties that we've done till now, the properties based on tangents to a circle. So one of the properties which is going to be helpful in solving this problems is that tangents from an external point to a circle are equal in length. So say we've got a lot of tangents as far as this diagram is concerned. We've got a circle here, then there are these external points, which is A, and then we've got B, and then we've got C. We've got two tangents from A, AD and AF, and then we've got two tangents from B, BD and BE. We've got two tangents from C, CF and C. So all these things are tangents from an external point. So from that property, we can establish that AD equals AF because tangents from an external point to a circle are equal in length. So AD equals AF. And then we've got BD equals BE. Tangents from an external point to a circle are equal. So BD equals BE. And then we've got CE equals CF. Again, because tangents from an external point to a circle are equal. So these are tangents from A, these are tangents from B, and these are tangents from C. So now what we've got is AB equals AC is already given, right? It's the data. So we've got AB equals AC. So now what we do is let's subtract let's subtract AD from AB and AC. So we get AB minus AD equals AC minus AD, right? So let's write AB minus AD as it is. Now, since AD equals AF, because tangents from an external point to a circle are equal, so AD equals AF. So here what we do is we replace AD by AF. So we've got AC minus AF. So now when you subtract AD from AB, all we've got is BD. And when you subtract AF from AC, all you've got left is CF, right? So now what we have to prove is we need to prove BE equals EC. Now, how is this going to help? Well, we know that BD equals B, right? Because tangents from an external point to a circle are equal. So let's replace BD by BE. And then again, we know that CF equals CE because tangents from an external point to a circle are equal. So therefore, we replace CF by CE. And here we are. We proved that BE equals CE. It's a pretty simple, straightforward problem based on the property that tangents from an external point to a circle are equal in length. So that is all you need to know. Once you know that property and you know how to apply it, you can solve this problem very easily. So let's quickly solve another problem before we conclude this video. Here we have another question which reads like this. ABCD is a quadrilateral such that angle D equals 90 degrees. A circle C of O, R, which means a circle which has got O as its center and R as its radius, touches the sides AB, BC, CD, and DA. So a circle touches four sides. And where does it touch? It touches at P, Q, R, and S respectively. So if BC is 38 centimeter, see this, if this is 38 centimeter, if BC is 38 centimeters, and CD is 25 centimeters. If CD is 25 centimeters and if BP, so yeah, we've got BP. BP is 27 centimeters, not BA, BP. So if BP is 27 centimeters, we need to find R. So R is nothing but the radius here, which is OR or OS. So this is R. So this is what we have to find. So how do we do that? So let's see how do we go about doing it. So now again, since tangents to a circle is perpendicular to the radius through the point, we've got angle ORD. Angle ORD is equal to angle OSD, right? The reason being, we've got this property which says that tangent to a circle is perpendicular to the radius through the point. So now it is already given that angle D is equal to 90 degrees. And also OR equals OS because they are the radii of the circle. So OR equals OS. And therefore we've got ORDS as a square. So we established that ORDS is a square. Now, since tangents from an external point to a circle are equal in length, that's another property which we've done a lot of times, and it's time that you get familiar with this property to solve a lot of problems. Now, since that is one property that we know, what all we can establish from that is we can say that BP equal to PQ, right? This is an external point and we've got tangent, so therefore BP equals BQ. And then we've got CQ equals CR. CQ, this is another external point, tangents drawn from here, so CQ equals CR. This is another external point, DR equals DS. Now we have BP equals BQ. BP equals BQ. And we've got BP equals BQ. BQ equals 27 centimeters. So now BC minus CQ should definitely be 27 centimeters, right? If BP is 27, BQ is 27, and we've got BC as 38. So BC minus CQ should be 27. So that is what it says. So BC minus CQ should be 27. Now we've already got BC as 38 centimeters. So 38 minus CQ equals 27. So therefore CQ equals 38 minus 27, which is nothing but CQ equals 11 centimeters. So we've got CQ as 11 centimeters here. So if CQ is 11 centimeters, we've also got CR as 11 centimeters because CQ equals CR. Here it is, right? So that's another thing. And then we've got CD minus CR is 25 centimeters, right? So if CD equals 25 and CR is 11 centimeters, 25 minus 11. So we've got CD minus DR equals 11 centimeters. So therefore, now CD is 25 centimeters. So 25 minus DR equals 11. So DR equals 25 minus 11, which is equal to 14 centimeters. So therefore, we've got DR is 14 centimeters. 14 centimeters plus 11 centimeters gives you 25. So if DR is 14, DS is 14 because DS is equal to DR, right? So now we need to go back to this point. ORDS is a square. If ORDS is a square, if this one, let me mark this with this color. If ORDS is a square, we've got this is 14, this is 14. So definitely OS and OR will be equal to 14 and 14. So therefore, we've got the radius of the circle. You know that OR and OS are radii of the circle. So therefore, the radius of this circle is 14 centimeters. How did we arrive at this 14 centimeters? Not very complex, very simple. You know, all we had to do is use the properties that we earlier did in the previous videos. That's all. So what it means is the more you're familiar with the properties, the more simpler are the problems gonna be. So I'll see you with more problems based on tangents to a circle in the forthcoming videos.